Hello everyone, good afternoon. Welcome to this session. Today we are going to solve for a centroid for a angular section. Okay, how to calculate the centroid for a composite section. Why I am saying that it is a composite section? We already said that one regular object called rectangle or square. Okay, we can have direct value of centroid if it contains more than one regular geometry, that is called a composite section. Now let's go for this problem. So it is a L section. Generally it is called in engineering point of view it is angle section. Okay, in angle section we have one web flange and this thickness. So the flange is 50 centimeter and the web is 60 centimeter and the thickness is 10 centimeter. And my question is, where should be the centroid at what distance? How to measure? Okay, so this is the thing we are going to do in today's class. Okay, first let's have when we are going to solve for a composite section to find out the centroid, we must have a reference point, because if let's have Madras to Madras, Coimbatore and Kochi, let's take it. Madras, CBE, that is the Coimbatore and Kochi. Okay, why I am going to take a reference point? From where it is to be measured, that is the question. From let's take, I am being here, it's my location. Okay, it's my location. From Madras to Coimbatore, it is, let's take a 500 kilometer, and from Coimbatore to Kochi, it is 200 kilometer. Okay, so what is the distance from my location to Kochi? So 700 kilometer. Okay, now let's take this is 500 plus 200 is equal to 700 kilometer. Okay, somebody is in Coimbatore. The same question is asked. The same question is asked by the person who is in Coimbatore. Okay, what is the thing? By having this concept, let's have from Coimbatore to Kochi, it is 200 kilometer. But we should not have this kind of methodology. Okay, but we should know from where it is started, from where it is measured. That is the very big question. Okay, very big important question here. Okay, same 700 kilometer we should not say. For that the origin we have to take for measurement. For that I am going to have one reference axis. The reference axis will be the first quadrant. Okay, the first quadrant, because here this quadrant only all the things that x and y are positive. Here x is negative, here y is negative, here both x and here both x and y is negative, here y is negative. So I am taking all the things are in positive direction. So it must be in the first quadrant. So the left extreme end, okay, consider the left extreme end and the bottom extreme end. This is x axis and this is y axis. So this is the methodology to be taken into account for finding the centroid. Because I am going to take from this point is the origin. Okay, like in letters I told you, no, so like that. Okay, this is the point from where I am going to measure the values for x and y axis. Okay, now I will just erase it here. Okay, how to find? We know that for a rectangle, the direct value for centroid at the midpoint. Okay, as in the earlier video. So it is a combination of two rectangles. So now we are going to split two rectangles. You just split like this or like this. So anyway, okay, whatever way we can split, no problem. So I will split like this. Okay. So I will take this is the section 1, first rectangle, and this is the second rectangle. Now consider the first rectangle, section 1. What is x, what is y? That means by considering this section alone, you just consider this rectangle alone. You just neglect the second rectangle. Okay. For that, from the reference axis, what would be the centroid? That is the question. Now you consider this one. Okay. This is the rectangle. Okay. What is the distance? Since it is 10 centimeter, it should be 40 centimeter. Okay. For rectangle, the centroid will be half of the value. So 40 by 2. 40 by 2. That's all. Is it okay? No, because I am going to measure the 40 by 2 from this point. This rectangle starts from this value. So this is the empty gap. So this distance also to be taken into account. So this is also 10 centimeters. This, okay, plus this half of the horizontal. Okay, so it is nothing but 40 by 2 plus this 10 centimeter to be added. Okay, so nothing but it is 20 plus 10, 30 centimeter. And y. Okay, what is y value here? So second section. For the same thing, okay, you measure from the reference axis in the vertically. Vertically it is 10 centimeter, so half of the value. Okay. So now I am going to measure this point from this point. So directly half of the value will be the answer for y value. So it is 10 by 2, which is equal to 5 centimeter. Okay. So I can take for section 1 it is x1, it is y1. Okay. Then let's move on to the section 2. Now let's move on to section 2. So consider this rectangle alone. So it is attached with the y-axis directly and attached with the x-axis directly. Okay. So x is nothing but half of the x value and y is nothing but half of the y value directly, because there is no gap at all. Directly attached with the x and the y axis. So x equal to, so x2 equal to 10 by 2, 5 centimeter, and y2 equal to total is 60, so half of the value 60 by 2, that is centimeter. Okay, this is for individual section, the centroid. So how can we combine these two, put together? How can we get the exact centroid value? For composite section, centroid x bar is the centroid and y bar is the centroid. So it is to be considered like this, x bar and y bar. Okay. So x bar is equal to sigma ax divided by sigma a. Okay. Now let's take area. Okay, let's take say capital A. So here the sum of area multiplied with the centroid of the particular section, okay, divided by the sum of the total area. So for section 1, what is the area? So here you consider the section 1. So this rectangle. So this is 40 into 10. Okay. So this is 40 into 10. So total is 400 centimeter square. For section 2, area A2. A2 equal to total it is 60 into 10. And this is 600 centimeter square. Okay. So here you can apply. This is first one. Area is equal to 400 into x bar. There is x1 30. plus for second section A2, that is 600 into 5 divided by the total area. Total area is equal to 400 plus 600. Okay, 400 plus 600 is equal to 1000. Simply. Then we will get into we will get the answer by substituting all the values and we get it. For x bar equal to 430, so 1200, this is 12,000 plus this is 3,000 divided by 1,000. So this is 15,000. Okay, this is 15,000. So cancel. So x bar equal to 50. Simply it is 50 centimeter from this value is measured from here only. So that the reference axis has been taken. Okay. Then what about the y bar? How can we find y bar? Same formula. Instead of x, we are going to apply sigma ay divided by sigma a. Use it from 400 into y value. Here y1 equal to here 5 plus and 600 into 600 into y1. So 400 into 5 plus 600 into what is the y value directly, it is 30. Okay, divided by it is 1000. So put over that this is 20,000, sorry, 400 into 5 2000 plus this is 18,000 divided by 1000. So this is also 20,000 divided by 1000. So finally 20 is the answer. So y bar equal to 20 centimeter. Y bar equal to 20 centimeter. The answer for this question, centroid is equal to x bar over y bar. X bar equal to 15 centimeter. Y bar equal to 20 centimeter. This is the answer. Okay. Here you can measure like this. X bar equal to 15. Okay, this is 10 and 15. 10 plus 5, 1. Okay, and y bar equal to 20. 20 means 10 plus another 10. Okay, so this is a point. Okay, so from here to here. Okay, this is 15 centimeter. And from axis this is 20 centimeter. This is the centroid. Okay, 15, 20. Like this we have to locate the centroid for the given composite section of angle section. So that's all today's session. We will see next session in the next class. Thank you.